Today I'm working on a Sony PVM 14L2 and the monitor works pretty much flawlessly, but there is a problem with the tube. First off, you can see the number 9 over here. So we have a bit of screen burning. And if you look over, you see the shadow on the U right here. See that shadowing and bleeding over. Same thing here, and you can see that 9 really well right there. Anyway, this one really has a that image will bleed through on blues and greens intensely. Just shows me that this tube has a ton of hours and usage on it. So I want to open it up and check out the tube that's inside of here. Hey, welcome into the CRT shop. My name is Steve, and today I've got a Sony PVM that I showed you has some blooming or bleeding issues where the colors and text on the screen, as you increase the brightness, it starts to bleed through an image and it just makes these weird shadows. So today we're going to check that out further and we're going to fix it on this PVM. But I did want to warn you, we're about to go inside of a Sony CRT PVM similar to this one right here. And you do need to take precautions if you're ever going to do that, or better yet, send it in to somebody who professionally knows what they're doing. That way you don't get yourself hurt. When inspecting inside this PVM, there's our tube setup. Now if we look over here, this one is from 2005. And then I cannot see the full tube number down there, but that's not as important as looking back here at this neck board. So what I've got is I can easily see the pin out here where it tells me what each pin numbered is, and then the vast majority of these are going to be marked. So this is like ground G1 or a ground. There's another G1. There's multiple G1s on this board. But you see we've got, this one is going to be blue, green, and red for 8, 9, and 10. And then H1 and H2 right here for 5 and 6. And then focus stuff under what you can't see. Now what I have here is a board from a salvaged repair stack. So this board has been cracked in shipping, and then I fixed it, and then I found a replacement board. So I just kept this after I tested it, and it works. And now I use it to test things when they come in. So again, this is from the N series. And if we look here, it does have a pin out on the back here. We have the same blue, green, and red up there for 8, 9, and 10. 5 and 6 are both our H1. Now 7 says no continuity, but if you notice, that's tied in over here with our other G1 on pin 11. The tube that is in a N series is probably completely compatible with this monitor. So I'm going to go find an N series monitor that's got a board that I can't fix, and hopefully the tube's still good and we can maybe swap it in here. So I'm referring to the Sony PVM N series monitor line, which is their entry-level PVM. They're generally lower quality than even the medical grades, and certainly anything in the BVM category. Sometimes these only supported composite video and S video. The one I have today had suffered a lot of damage in shipping, and all the boards were pretty much destroyed. Let's take a closer look at that one. I've got this N series opened up and all the boards removed out of it. This yoke assembly is the same. It just has one number earlier on manufacturer's number or model number right here. If we look and compare that to our L, there you go. It's just a -12. And there's the same plug right here. So the good news is we won't have to do anything with the yokes to get those to function. We're going to take a look at that tube number over there, because here's the one over here, M34KBE11X. I finally dissected this PVM, and check it out. This is the same model tube as our N series over here. The model numbers are exactly the same. We just have a blue label here from a made in Japan tube. And then over here, this is an orange label made in Singapore. Again, the yolks are an exact match, so we're literally going to swap this out. I've got everything ready here to run the first check and test. And naturally, I would have gone in here and quadruple checked everything, made sure everything's connected properly, and put back together right. The anode cap is seated good, nice and snug. I've got a signal going in there, RGB, and we're gonna throw the same Super Nintendo signal in here. And this is it. It's either gonna work or it's gonna be a bust. Let's just see what happens. Definitely a delay there to come on. Should still be in the normal RGB mode. There we go. Okay, but I'm not getting my video signal. Oh, I didn't turn this on yet. Let's turn it on. I hear it getting a video. Oh, there we go. Okay, good. All right. Well, that's actually quite good. Look, we've definitely got a convergence thing going on. I think that's just going to need a little twist on the horizontal static convergence tab back there, you see. But obviously no 9 in the corner. And I do not see that same color bleed effect. Just a little bit of a convergence-ish adjustment problem here, which isn't surprising considering it's a new tube combo with the chassis. But yeah, looks like we got something good in here. Let me see if I can get set up and make that little adjustment. All right, here's a good monoscope test pattern. So we can see, let me turn the brightness down. But you see how we have color separation here, where we have red, green, and then blue right there. It's not all white. What we need to do, since this is a horizontal adjustment, we can align those beams by spinning that little potentiometer right there, that white one on the neck board, surrounded by that gray case. Of course, it's not the easiest one to get to, but spinning that will correct this convergence. All right, I did manage to get it cleared up, but to be honest with you, it took me a while because that's one of the most dangerous ones to try to get down inside there and get access. So what I had to do was I had to adjust it a little bit with it turned off, turn it back on, see what happened, and slowly back and forth did that till I got a pretty good result. So if we look closely, kind of in these areas, you could see that white is more uniform. We don't see the bleed over where everything has the little red, white, and blue, or I'm sorry, red, green, and blue. Instead it makes white, instead of seeing a little hue around everything. So that's really good results. And this thing is looking very nice. I'm going to let it warm up for a little bit, and then we'll see if this tube remains stable. Well, the tube seems to like its new home here in the PVM 14L2 because it's running great. So I don't see any of those issues that we had with the original tube, obviously, because this new tube had a lot less hours on it. And it's really just looking great. I'm going to continue to let it run, but I don't anticipate any problems from this from now on, at least involving this tube. Of course, unless I left it running for 10,000 hours with another number on there and got more screen burn. But for now, we're not going to do that. All right, so I want to get in here and find this CRT that we took out of that 14L2 and take another closer look at it. Okay, let's look in here and see if we can't find that tube. I can't find my ladder. We're going to just stand on this. Oh, and here's the tube graveyard. It's somewhere, because there's the frame for that one. So it's going to be one of these up front. I think it's this one, maybe. That's the right tube number. We should be able to see pretty much right away. If there's got 9 there, can we see a 9 down in that corner? Yes. Okay. You see that 9? This is definitely our tube. So now here we have our old tube, and I've gone ahead and connected some probes here to pins on it, and we are going to use this tool right here. This is what we call a CRT restorer and analyzer. It's the 467 CRT Restore and Rejuvenator. There's a lot of great information about this device on the CRT database, and I will put a link to that below in the description for the video. So what I'm going to do is I've got this device connected already to this old tube. We're going to run an analysis of it and see the condition of it. I have it hooked up here where we have this being blue, green, this is red, G1, and then let's see, H2, H1, and G2. So that's all the pins I need to have. This is to run a test. So those pins are all connected. So now we can set up and use the analyzer here. I'm going to tilt it up like this so you can get a better idea of how this will work. And first off, there should be more markings on here, but mine have rubbed off. We're going to turn it on to the first one, which is setup. You see we have power on. And for our heater voltage, we need to be right on 6.3 volts for this tube. Looks like we're a little high on that, so we can dial that down just a little bit here since we're on setup mode. And I think that right there is 6.3. If we look at that directly on, maybe a little low, so let's gotta like give it a second to stabilize. Okay. So that's what we wanted. We wanted 6.3 volts here. So over here we have the heater range at 4 to 7. We're at 6.3. Now this one is telling me my G1 voltage down here. And then another thing over here is my line voltage. Now I have verified this. As you can tell, it's right under 120 volts AC. And that's exactly what's coming out of here. I've used a meter to verify that all this is calibrated properly. 50 volts there. That's all set up properly. Now the next thing we just need to do is move over to set cutoffs, which is the middle one. And then we can use these 3 dials to set these cutoffs. Our goal here on the cutoffs will be to have each cutoff be set to one interval, like right there. See, that's one interval over 0. Each one of these needs to be set to that interval. This one's a little high right there. This one's a little low. And we can give this some time to sit here and warm up. I mean, you can give it a minute if you want to. Now, if you notice, we're getting a lot of lights in there. You see that cathodes light up, or the electron gun in there is lit up. Let me turn the lights off in here. And maybe we can see that better. See how that's actually glowing down in there? So we are just energizing those with a little bit of voltage. That way these probes can get a reading. And so we've got all of it set up here. Let's go over and we'll just run a test. Get the lights back on here. Let's run the test. Now this is not invasive, just to test it. Literally, we just have it here. Yes, everything's still on 1. It's stable. Whoa, my power button's just sliding off there. I need to just go over 1 to test. And yeah, look at that. Woof. we have really low emissions. So this is our red emissions. We're in the bad zone. We're in the bad zone even lower over here. And then we're still in the bad zone over here in blue. So the best of the three is the red gun, but these are all really low. So since this tube is not being used for anything else, let's have some fun and just go ahead and see if we can get this to actually do a clean and balance, which is the lower form of the rejuvenation process that this can do, where it's going to just send some electricity through these lines and try to clean that off and maybe get us a little bit better emissions on this tube. Let's just see what happens, because we have really no other use for this tube. Okay, let's start the procedure. Now, the next thing we would need to do is move from this test mode over here to the clean and balance mode, which we move over to the restore tablet here. And what we're going to do right now is we're going to let this warm up for 30 seconds. And it says to observe in here, and we have gotten even more brighter lights inside this cathode ray tube. We've got it right there in the electron gun, and that's supposed to happen. So after 30 seconds, what we can do is we can start to do the rejuvenation process, which is, again, this is the lower energy rejuvenation process. And what I'm going to do is I'm going to follow it. So I'm supposed to come over here, and we're going to start with our, let's start with our, do red last. Let's start with green, and we're going to hold this, and hopefully this should jump up, and then it should start to balance out a little bit, and then it should fall. And once it gets to that 0.2, I'm supposed to release it. Now, sometimes that happens, sometimes that doesn't. If I don't really want to hold it down too long, because what I'm going to do is I'm going to leave the camera in this kind of an angle so I can watch it, and hopefully if it starts flickering inside this, we will see. Now I'm going to turn maybe the lights down, and let's see if we notice this get any kind of extra glow to it as I press this down, or if it starts jumping around. So I'm holding it down. You can see it get lower. It's starting to fall to 0.2. It's getting there, it's getting there, it's getting there, and I'm letting it go. And now it's heating back up. Now let's go over here and to get a test on it real quick. Boom. Wow. Okay, let me turn the lights on. And everything went up a little bit. So I'm actually going to go back to setup. And I'm going to check and make sure everything's still good on this. Well, I'm not even, those are the wrong adjustments. I'd have to adjust these, but these two still look good. Everything looks good on that. Let's go to setup cutoff again. This could have changed. And we got a little bit higher on blue. Let's adjust that down. And man, that's a little low on green. Now let's do a test. And wow, look at that. So we've recharged the green here all the way to in the good zone, and I mean it's holding good. And so let's just do that same thing on the clean and balance. Now we're going to do the blue, and then finally we're going to do the red, but we're going to do blue next. So all I need to do is move from that mode over to this mode, and we'll let it warm up again. And then I'll cut the lights out again so you can watch that tube glow, and it should just like start to kind of get lower on the glow as I press the button. So I'll tell you when I'm pressing the button here. We're going to let it warm up just a little bit longer, and then I'll press this blue button, and I'll watch this dial just like I did with the green, and I'm going to get you a close view up here of the tube, and hopefully we'll see what the glow does as I do the blue. Here we go. I am pressing the button now, and it's steady, dropping down to 0.2, 0.2, 0.2. There we go. And I've released the button again. And let's just reverse this back one more time. Actually, let's turn the lights on. And now let's see what our test is going to show. Holy moly. Now the interesting thing is I feel like this is still pretty much stayed around 0.4. I feel like all of them get a good little kick from just the one. Maybe it's since it's a cathode ray tube that has a Trinitron gun in it. It's using one gun with just 3 different color lines on it. Maybe that's the actual reason that it's getting a little bit of juice, feels like, to these other colors as you do these two. So what I'm going to do finally is I'm going to do the red also. But I think that in the past I've been warned about the red being like the most fragile of these lines and these Trinitron tubes. So I'm not going to try to hold it as long as the other two colors. Maybe just a little bit less. So let's go ahead now here. We'll set it over to restore. And we're literally going to do the same thing again for red. And this time I'll get this kind of an angle so you could see me as I hold this and watch this. And this will bump up a little bit. And then we're going to let it go. I'm going to let it warm up just a few more seconds here because I do want to give it that warm-up time period that it says. All right, so let's just check this out and see. Okay, I did it about half the length, maybe a little bit more than half. Let's see what happens. Oh, baby, look at that. Wow. Okay. It's starting to get the reading. And let's see how we get. Wow, we got all those actually to like a good, stable, safe, pretty close range here. Blue's a little bit lower. Green's a little bit lower. Red's a little bit higher. Isn't that interesting? Wow. So there we go. We've got our test done, and that's a way to get these Trinitron guns back up into the green. Now, this tube is just going to go into the storeroom and be saved in case we have one that comes in here with a tube that's actually missing a color, because it still has tons of hours on it. And but it's reading good. Let's just go back here again. Let's make sure the cutoffs are all right, because those can fluctuate after doing that. Blue looks like it jumped a tiny bit. Let's get that dialed back. Green, maybe just a tiny bit. Let's go and see. Do another test just like that. And that's it. Wow. So we don't need to do the rejuvenate process. That would be even more voltage going into there. And that could actually damage this thing, I imagine. So I removed the testing equipment, and I can tell you that I'm feeling this neck of the CRT right here, and it is really hot. So we were definitely getting some high voltage sent through that tube right there and into the gun inside there. And so you could tell that just by when you touch that. I mean, it's very warm. Now, if I come around here to the front of this tube, hopefully we'll be able to see the issue that still remains with it, and that is over in this corner. See if I can get it to show a little bit better. Yep, there it is. Okay, we can see the number, see the shadow of the number 9 burned into this corner down here. We already knew that this tube had a ton of hours on it, so it still has that number 9 burnt into the screen. The other thing is the ghosting effect that you saw. The CRT rejuvenator really won't have any effect on that. At least it should not. It's not really something that would be cleared up from my knowledge from that. If I do get an opportunity to test this by swapping this tube into a fresh CRT, I will definitely make a follow-up video to this one to update you and show you what this looks like. Because the tube that I have in here for this one in the 14L2 now is really good and works wonderfully. So I'm not going to take it all apart and reinstall this tube just to see how it looks in it. All right, I got a couple of final notes that I'd like to talk about here with this CRT tube testing and basically trying to repair a CRT tube. First off, you really need to be careful when using one of these BK467s or really any of the rejuvenation tools. Mine had to be fully restored and rebuilt before I was able to even use it ever. Also, I had to hand build that little adapter that you saw me use today to test the tube. And then finally, I regularly go through and check the calibration on the machine to make sure it's all proper. Because if anything is incorrect on there, there's always a chance that you could damage the CRT you're trying to work on. Now look, this is testing on this as far as like getting that emission test. That's a really non-invasive test. There's no damage done to the CRT, even though it does heat up the cathode. I've never heard of any CRT actually being damaged from just setting it up to run the test. However, running the rejuvenation, even just the clean and balance level, you are always running the risk that you could end up shorting out your cathode on the tube, and then you could render either a single color completely gone and useless, or you may even short out something on the tube where it doesn't even function at all really anymore. I have had that happen before when I tried to run this test on a Sony PVM years ago. The tube was already bad. I tried to run and clean and balance, and it fried the tube out completely. I've talked to plenty of other people who've had that kind of experience, so please take caution and make sure everything is right before you actually go and do that clean and balance or rejuvenation process. Now, there are other CRT testers and rejuvenators available. As a matter of fact, there are tons of them on the market from other brands, not just BK, but there's also Sencor. There's quite a bit more information on the testers, again, on the CRT database. Andy King and everybody over there, Matt Ross, they all did a fantastic job putting together this documentation, and Sterling. They all put it together there. So if you need more information on these tools, I would really suggest you check out that link to go look at it and see if one of these is right for you. Nowadays, these tools can be quite expensive. The best place to try to find them is on eBay or on CRT repair forums, generally on Facebook. Sometimes they pop up on there as being for sale. Now today, look, we got really into the CRT weeds and the really nerdy topics of tube repair, and so I really appreciate you hanging out to this point. One final note, I guess, on CRT repair: you cannot fix CRT burn. There's no real way to get rid of that. And that streaking should not be removable, but maybe we could get rid of that, possibly, but I see no possible way to ever get rid of the burn in a CRT. But just because a CRT has burn does not mean it's completely useless. This has such light burn that we are guaranteed to run into another CRT that has this tube, this model tube in it, and it's going to need a better tube. So hopefully we'll get to install this tube, and I promise if that happens, I will make another video and follow up to this with that, no matter how long it takes for that to happen. Again, thank you for getting into this extremely long video. It kind of turned into a much longer thing than I really anticipated. If you need any professional help with CRT stuff, the best place you can go is my Patreon, and you can DM me any issues you may have, and we can talk about that through DMs, or you can even get service work lined up, and that all can be done through Patreon. Thanks again, everybody. I hope you have a wonderful rest of your day, and if you did enjoy this, please drop a like for me, and I'll see you next time with some more retro content.